When we design algorithms or AI systems, we want them to respect certain values, such as fairness, explainability, privacy, and sustainability. But how do we design algorithms and AI systems for values? Over the past decades, a number of approaches have been developed to this end. They go by names like value-sensitive design, design for values, value-based engineering, and value alignment. Today, we focus on the basics of the value-sensitive design approach. The value-sensitive design, or VSD approach, has been developed since the 1980s to design for values in computer science, but it has been applied more broadly since. At the core of the VSD approach is a tripartite methodology of empirical, conceptual, and technical investigations. Empirical investigations are aimed at understanding the perspectives of all relevant stakeholders. Conceptual investigations are aimed at better understanding the values at stake as well as trade-offs. Technical investigations are important for designing the technology itself. Let's take an example. Suppose you want to design an algorithm that supports local farmers in Africa in cultivating certain food crops. Several studies estimate that there is great potential for AI in the agricultural sector, but how do you ensure that you really help the local farmers and what values should you then design for? You might think the most important thing to optimize is crop yield, but we will see that things might be more complicated. In this case, the empirical investigations might start with a literature study to better understand the relevant context. One important question is who the expected users are. Are these local farmers? And if so, shall we focus on individual farmers or on a family or perhaps their cooperative farmer or even entire villages? And are these farmers producing for the market or rather for their own use? How much can they afford to spend on your application? And what expertise do they have? Do they have a mobile phone? Can they afford to have a bad harvest one year, if that's compensated by better harvest in other years? Or may they then be plagued by hunger? These are some of the relevant questions to ask. In the empirical investigation, you interview relevant stakeholders. These are not just the users, or what's called direct stakeholders, but also indirect stakeholders who are indirectly affected. Perhaps your algorithm will advise farmers to use other fertilizers, which may affect suppliers. Or perhaps, in the past, your surplus harvest went to a family member, and the algorithm will spur the farmer instead to sell it on the market. In the conceptual investigations, you may formulate the relevant values, try to better understand what these values exactly mean, and how the various values might be support each other or are tension. In this case, relevant values may include economic prosperity, food security, income security, well-being, privacy, cybersecurity, and sustainability. Now let's take the value of well-being. How should we understand well-being in this case? To answer such a question, you might look at relevant philosophical theories. For example, the philosopher Martha Nussbaum and the economist Amartya Sen have proposed to understand well-being in terms of human capabilities. The idea is that humans should be free to choose how they live their life, but that certain human capabilities are needed for all to be able to live a good life in well-being. Relevant capabilities in this case may include the ability to produce enough food for living and to be able to make independent choices. Now, at this stage of the value-sensitive design process, you may come to the conclusion that the main value to be optimized by your algorithm is not, as you maybe initially thought, crop yield, but rather food security. Studies suggest that food security requires attention for sustainability and cybersecurity and not just for crop yields. Or perhaps the most important value may turn out to be decreasing the dependency of local farmers on international supplies of seeds, fertilizers, and pesticides. Obviously, different values will result in quite different technical choices. And this brings us to the technical investigations. What kind of algorithm will you design? How much and what data does it need? How are these data to be collected and stored? Will it operate on a local server? Can it be accessed through a mobile app? How much bandwidth is needed? This gives you an idea of how a value-sensitive design process might look like. What is important is that the three types of investigations we have discussed may require quite distinct expertise. Empirical investigations require some expertise in social science. Conceptual investigations may require some knowledge of philosophy and law. and technical investigations in computer science and engineering. Value-centered design is dus een multidisciplinary endeavor, which might require design teams with people from different disciplinary backgrounds.